All right, let's dive right into this explainer. We're looking at the 1982 Tylenol crisis, specifically the science and the leadership behind it. It's this incredible historical moment where microscopic evidence slammed right into macroscopic executive decision making, and it literally revolutionized both forensic chemistry and corporate leadership forever. We're starting with a staggering number: $100 million. That was the cost of an unprecedented product recall. It was a massive bet-the-company business decision triggered by a microscopic killer. And honestly, it set a precedent that completely changed how consumer goods are handled today. But to really grasp how we got to that $100 million mark, we've got to go back to the beginning. Section 1. The Tylenol poisoning crisis, a tragic crime in 1982. So picture the fall of 1982. The Chicago Tylenol murders send absolute shockwaves through the nation. We're talking about cyanide-laced pills causing fatal poisonings, which naturally sparked massive public panic. I mean, the threat was totally invisible. It really begged this terrifying question: how exactly do you catch a microscopic killer? Well, investigators realized pretty quickly they had to pivot from your standard police shoe leather work straight into the highly technical world of chemical forensics. Section 2. The science of trace evidence, qualitative analysis in forensics. Let's zoom in a bit to the microscopic level. How does modern forensic science actually identify an unknown substance? It comes down to qualitative analysis. This is the methodical use of scientific methods to figure out the exact chemical identity of a substance without even worrying about the quantity. Determining that chemical identity, basically finding its molecular fingerprint, is the absolute critical first step to providing solid scientific evidence in a court of law. It's not about how much of the stuff is there just yet. It's entirely about what exactly it is. When we look at the main analytical tools used in modern forensics, there are three heavy hitters. You've got FTIR, which works by measuring infrared absorption. That one's non-destructive, making it perfect for solid trace materials like fibers. Then there's Raman spectroscopy, which measures inelastic laser light scattering, also non-destructive, and it's heavily relied upon for field testing things like explosive residues. But for the Tylenol crisis, we really need to focus on that third method right in the middle. Section 3. GCMS, the gold standard for catching cyanide. Gas chromatography mass spectrometry, or GCMS. It is universally accepted as the gold standard for the confirmatory identification of volatile compounds. It uses this brilliant, rigorous two-step process. First, you have gas separation, which isolates the mixture's components by passing them through a mobile carrier gas, right? Then comes step 2, mass fragmentation. This literally disintegrates the ionized molecules and sorts them out by their mass-to-charge ratio. By hitting the sample with this dual approach, GCMS practically drops the probability of misidentifying a substance to near zero, even if you're dealing with incredibly complex mixtures. And here is the crucial takeaway. It was exactly this GCMS testing that positively identified the fatal cyanide levels in those Tylenol capsules. The science stepped up and provided the undeniable proof of the cause of death. But, as you can probably guess, knowing the what and the how was only half the battle. Now, someone had to take action. Section 4. The corporate crisis response, a macroscopic business decision. Now that the science had successfully pinned down this microscopic threat, we have to pan out to the macroscopic level. Enter Johnson & Johnson's CEO, James E. Burke. And Burke wasn't just your run-of-the-mill executive. Think about his timeline. Between 1941 and 1945, he's a WW2 Navy ensign, literally commanding a landing craft tank in the Pacific. After the war, he snags a Harvard MBA in 49, joins Johnson & Johnson as a director in 53, and works his way up to CEO by 1976. This background, being a wartime commander paired with being a risk-taking product developer, it uniquely prepared him for the absolute storm that was about to hit his company. Faced with those horrific forensic findings from the GCMS tests, Burke had a monumental choice to make. And he chose to prioritize public safety over short-term profits. Without hesitation, he ordered an unprecedented, nationwide recall of 31 million bottles of Tylenol. He willingly swallowed that $100 million expense we talked about earlier, just to guarantee that not one more person would be harmed. And then, he boldly spearheaded the relaunch of the product, featuring a brand new tamper-proof design. His radical transparency and immediate, decisive action did something incredible. It transformed what could have easily been a fatal corporate death blow into the absolute gold standard for crisis management. I mean, his actions became a prominent case study for successful crisis management, and they still serve as the standard for numerous business practices taught in schools today.
Section 5. A lasting safety legacy, protecting the public today.
Let's look at how this unbelievable intersection of forensic proof and executive action permanently changed our world. Doing the right thing ultimately paid off, and I mean massively. Under Burke's tenure, company revenue actually tripled to over $9 billion. He navigated Johnson & Johnson through its darkest hour, straight to unprecedented success. And for his courage and leadership, he was later awarded the Presidential Medal of Freedom.
But his legacy, it extends way beyond just profits. Because the GSCMS chemical results were so definitive and scientifically ironclad, Burke was able to point directly to the product's vulnerability. He spearheaded those tamper-proof packaging regulations that, let's be honest, we all totally take for granted now. Today, forensic labs use rigorous cross-validation between multiple techniques to hit those internationally accredited safety standards, all to ensure that what happened in Chicago back in 1982 never, ever happens again.
So I want to leave you with this final thought to chew on. How does the invisible science of yesterday and the visible leadership of the past protect our society today? The next time you safely open a bottle of medicine, when you snap off that plastic ring or peel back that annoying foil seal, take a second to remember the microscopic chemistry and the boardroom courage that made it possible. Thanks so much for joining me on this explainer, and I hope this helps you look at the everyday world around you just a little bit differently.